Let's now take a look at how we can determine the interest rate term structure under the CIR model. So under CIR model, we have a form that the short rate follows this particular process, mean reversion, and we also have this square root of R term, which actually prevents interest rate to become negative. Now, again, following the same analysis that we seen earlier, we will have this particular partial differential equation when we put in the relevant parameters here. So for this for the drift and this for the volatility square. So note that compared to the Veselchak model, so instead of have a sigma square, we now have sigma square R. But nevertheless, the solution of this partial differential equation still has this same generic form here, okay? Although certain actual formulation or the actual expression for A and B will be different, but the general form is still the same. Now again, we can use the boundary condition. The zero coupon bond will becomes 1 when it matures to solve this PDE here. Now the solution will be this. And so essentially, you see that the CR and Veselchak will have the same generic form, but they will have different expressions for A and B. So, and the one under CIR is more complicated than the one under Veselchak. Now, you see that under either the Veselchak or CIR, once the parameter of the process is determined, essentially the shape of the entire term structure is determined. Okay, so under both structure, they have the shape of the interest rate curve or the interest rate structure is very similar. So both of them allowed for this kind of flexibility in terms of the shape of the interest rate term structure.